Okay, this is our second video in integrals review, so this one's probably going to be the shortest of the three. We're going to look at the integral of 5 to the x plus 5e to the x. And so just as a reminder, the integral of e to the x is very easy, e to the x plus c. And the integral of b to the x dx, where b is a base, not 1, not e greater than 0, that's going to be b to the x divided by the natural log of b plus c. Okay, so the integral of 5 to the x is 5 to the x divided by the natural log of the base, natural log of 5, plus the integral of 5e to the x is 5e to the x. Don't forget your constant of integration. That's it. Okay. So one of the applications using the second fundamental theorem of calculus is we can find the area between curves. So we're going to find the area bounded by the parabola f of x equals negative x squared plus 7x, bounded by the x-axis and the vertical lines x equals 1 and x equals 4. It's important to get at least a decent sketch. It doesn't have to be a beautiful sketch, but the important things like what's the upper function, what's the lower function, where things intersect, that stuff should be able to be displayed there, but it doesn't have to be perfect. So we'll go ahead and do a sketch. So we're going to start at 1, and if I just plug in 1, I'm going to have negative and then 1 squared plus 7 times 1. So it's going to be negative 1 plus 7, which is 6. Okay. I'll plug in 2. It's going to be negative and then 2 squared, which would be negative 4 plus 7 times 2, which is 14. So it's going to be 10. Then we'll do 3. Okay, so that's going to be negative and then 3 squared. So that's going to be negative 9 plus 7 times 3, which is 21. So 21 minus 9 should be 12. Okay, and then plug in 4, that's going to be negative 16 plus 28, so that's going to be back at 12. The vertex, if you remember, is going to be, let's draw with a highlighter, it's going to occur at negative b over 2a, so that's going to be the linear coefficient divided by the quadratic coefficient. And so that's going to occur at 3.5. If we want, we can plug that in there also to find the max there, but we don't need that for this. We just need a decent sketch. Okay. Okay. So bounded by x equals 1, bounded by x equals 4. Those are those vertical lines. There's your parabola portion, and then bounded by the x-axis. So we have all that represented, even if my picture is a little bit ugly, but we can just pretend it looks nice. Okay. So we're going to go ahead and find the area. Okay. And so the area, we're going to be finding kind of the heights of the rectangles. So this goes back to the Riemann sums. And so the height is determined by negative 7x squared plus 7x, negative x squared plus 7x. Then the bottom is just the x-axis. So the height is just simply the parabola. Okay. And so we got a definite integral. Okay. So we'll go ahead and add 1 to the exponent and divide by that exponent on each one of those, and then we're going to go ahead and apply the fundamental theorem of calculus. So if we have the integral from a to b of f of x dx, and we know what the antiderivative of little f is, it's big F, then this is just going to be f of b minus f of a. Oops. So that's just your fundamental theorem of calculus part 2. So that's what we're going to do here. We're going to go ahead and evaluate this function at the upper limit and then subtract from it the function evaluated at the lower limit, and that function being the antiderivative here. You don't need to put the plus c for definite integrals because it will always absorb. Okay. All right, so we're going to plug in 4. So that's going to give us 4 cubed, which is 64. 4 squared is 16. Minus, and then evaluate at the lower limit. 1 cubed is 1, and 7 squared is, 1 squared is 1, so we just get 7 over 2 there. Okay. All right. So let's go ahead and simplify a little bit. So negative 64 plus 56 And then we'll distribute the minus sign there, so that's going to make that a positive 1/3 and a minus 7 over 2. Combine your like terms, and so that's going to be negative 63 over 3 plus 56, minus 7 over 2. Negative 63 over 3 will reduce to negative 21 plus 56 and minus 7 over 2. So it's going to be 35 minus 7 over 2. And 35 is 70 over 2, so we get a common denominator, minus 7 over 2. So we get the exact of 63 over 2. Okay, so that's the area there. We could say 63 over 2 square centimeters, inches, whatever the units are involved. Okay. All right, we'll look at one more here. We're going to do the integral from 4 to 5 of 1 over x squared dx. So this is a definite integral. It has limits of integration. Lower limit is 4, upper limit is 5. Go ahead and rewrite this integral from 4 to 5 of x to the negative 2 dx. Add 1 to the exponent, and that makes it a, well, I guess I didn't do that. That make that an x to the negative 1 over negative 1, okay, which we would rewrite that as negative 1 over x, evaluated from 4 to 5. So it's going to be a negative 1/5 minus negative 1/4. So get a common denominator, so that's going to be negative 4 over 20 plus 5 over 20, which is going to be 1 over 20. And so that would represent the area under 1 over x squared between 4 and 5. Okay. All right, so that's it for this video. In the next video, we'll look at a couple of examples of U substitution, a technique of integration.